I'm like equal. Yeah, like where I live is like equidistant between
Wayne has limited
right on the stage.
I knew that going in today. It's beautiful. It's northwestern Florida. It produces the cyclone.
I thought it was, I didn't know there was another break.
Do 2 flights Monday afternoon, Tuesday night. Sample the upper.
I still saw problems.
Yeah, they may still do. It doesn't look like people shows up.
Okay. Hello, I've been given the go-ahead to get started. My name is Amanda Latham. I'm an outreach specialist with the State Climatology Office. And as we've been doing for the past couple of months, I'm going to give a little update on what we saw last month. So even though we're in mid-November, we're going to look back to what we saw in October in Wisconsin. So big highlights were summer really hanging on through a good part of the month, at least the first half of the month. We did get a decent amount of rain systems, but not a lot of rain came from them. And so with that, drought really spread through the state throughout the entire month. So really, in my opinion, the only exciting thing that happened during the month was that first week when it was really, really unusually hot. So these are the average high temperatures across the state for the first week of October. Anywhere in that darker orange is an average high of about 80 to 85 degrees. And you can see even farther north in that medium shade of orange, it's an average high of about 75 to 80 degrees. So no surprise, this was much, much warmer than what we would typically expect for early October. Anywhere in red, that's about 10 to 15 degrees warmer than the average highs for early October. Those swatches in pink are where temperatures were closer to 20 degrees warmer than average. So during that week, a lot of records were broken. The hottest conditions were right between October 3rd through 5th. During that time, 18 records were broken across the state, at least that were reported by the National Weather Service. There may have been some smaller stations that broke some records. Some notable ones, Green Bay tied their record for their hottest October temperature. That was 88 degrees on the 3rd. La Crosse reached 90 degrees on the 3rd as well. That was only the 5th time on record that they've reached 90 in October. And then Madison, we also broke a daily high record on October 3rd of 87 degrees. So really to show how unusual these temperatures were, these are the average highs for the first week of July, much more similar to what we saw for the first week of October. So really unusual heat that lasted through that first week. Even the low temperatures were well warmer than average. It does look not as intense because they are low temperatures, but notice right along the lakeshore, Milwaukee, and then down into Kenosha and Racine counties, some of those areas saw average low temperatures around 60 to 65 degrees. The rest of the state saw those average lows about 50 to 60 degrees. And again, that is much, much warmer than what we would typically expect our low temperatures to be in early October. And so to put that in perspective, many of those morning lows were closer to where those average highs should be for the first week of October, and especially areas farther north, closer towards Wausau, Rhinelander, Green Bay, saw those morning temperatures for the first week of October closer to where they would expect their afternoon highs to be. So just really unusual for that first week of October. Sticking with low temperatures, in general, our lows were pretty mild through the month of October. Average lows across the state about 40 to 50 degrees in many places. That was about 3 to 5 degrees on average, warmer than average lows. And that did actually have an impact on our fall colors. Now, this isn't really a scientific comparison. There's no real scientific way to track the progress of fall colors. It's all based on people reporting where those fall colors are at throughout the season. But when I looked at it on October 15th, this is what we would typically expect to see. Northern Wisconsin past the peak fall colors, central and southern Wisconsin getting closer to peak fall colors. And you can see on the right, that's what Travel Wisconsin was reporting for October 15th. Just a few counties in northern Wisconsin were closer to that peak, and southern Wisconsin was pretty far from those peak colors. So overnight temperatures dipping closer to freezing, but not falling below freezing. So those cool overnight temperatures are really key in signaling to the trees that it's time to get ready for winter. But because our overnight lows were so warm, kind of kept them in that summer mode, and they didn't stop producing that chlorophyll as soon as they typically would have.
That's causing problems too for me anyway, I'll say. The city is coming by this week in my neighborhood for the last leaf pickup. Mm-hmm. It's the first leaf pickup, and it's really late, so everything was so late. I got to get home today and rake.
And I know me personally, there are still a ton of leaves on my trees by my house.
Is that right?
So yeah, so I'll still have to clean them up myself. Yeah.
The city has not kept up with this particular fall.
I'll have to send it to them.
Yeah, right.
All right, so overall, our average October temperatures make sense. They were warmer on average. We did get a little bit cooler later in the month, closer to average or a little bit below average, but for the month as a whole, average temperatures were about 3 to 5 degrees warmer than average. So here's that cooler stretch that we had later in the month. Right around October 23rd, many places saw their first freezing temperature, which ended the growing season. But that is much later than typical, 2 to even close to 3 weeks later than typical for that first freeze. So that did mean that farmers had plenty of time to get their crops in and actually led to a record-long growing season in both Wausau and Green Bay. So that was thanks to that late final freeze in the fall, but then also a early final freeze of spring, as our March was very, very warm. So they got out into the fields early and they could stay out into the fields later in the season as well. For precip, it was a pretty dry month. Most areas averaged about 1 to maybe close to 2 inches across the state, even less in the far northwest corners. That's where average precip was about 1/4 inch to 1/2 inch. You can see deficits on the right-hand side there. Any area in red, that's 2.5 inches or more below average for the month of October. There was only one little sliver of Buffalo County that reported a surplus of precip, up to about 1/2 inch surplus there. What I found very interesting was that it wasn't for lack of rainy systems. So one of our assistant state climatologists went back and looked at the average number of rainy days that each first order station sees in October. Most of them see around 10 days. Now for this month of October, most of those stations were either at average or even above average. So lots of small rainy systems came through, but they just weren't producing a lot of precip. I do suspect if we looked in the northwest corner, we don't track any of the stations there. If we looked at Hayward or up in Superior, I suspect they would have a much lower number of rainy days than what they typically see. As temperatures got colder later in the month, we did see our first wintry precip. Some graupel was reported in Milwaukee on October 22nd. And the next day, there were a couple flurries reported just north of Rhinelander, and that was the first flurries in the state. I think a couple other places in far southern Wisconsin near the state line reported a couple flurries with some graupel right around Halloween. So with all the dry conditions, it makes sense that drought conditions got much worse. Here's where we started out the month. Large area of abnormal dryness for areas in yellow through northern Wisconsin and down towards the east, including much of southern Wisconsin. A small swath of moderate drought off towards the northwest, and just a portion of Green and Rock counties in far southern Wisconsin. Here's where we ended the month. Interestingly, the areas of abnormal dryness didn't change very much, but there was a slight expansion of that moderate drought in the northwest, in addition of some moderate drought towards the east. And then a small area of severe drought emerged right on the border of Lafayette and Greene counties. That is the first severe drought in Wisconsin in nearly a year. If you were around Madison last year, you remember we had a very wet summer. Things got very dry through the fall and then continued to intensify through the fall. So we're seeing a kind of similar pattern, not quite as intense, but a similar pattern to what we had last fall. And so that is my little preview of our summary. We did just post the October summary today in full, so if you're interested in reading that, you can go to our website and do that. Always email us with any questions and see some fun things we post on our social media pages. Thank you.
Great, thanks. That's great, thanks so much. Professor Morgan was saying to me today, I hope I didn't overstep by saying yes to the State Climatology Office request to take a little bit of our discussion time. And then we both kind of agreed, don't even ask. Just inform us that you want to use it, because there's no request. This is not our turf. And that was great. It's the second one we've had, and we're really, really happy to have those updates and delivered. A third one?
Yeah.
Oh yeah, well, that's right, that's right.
Did one too.
That's right, that's the third one. So, and they've all been just excellent, and they're a great addition to what we're doing here every Friday afternoon. So thanks so much for putting that in. But don't feel that you have to displace us. It's not how we feel about it. What a week. We had Northern Lights that I didn't see. I went out my house. I saw all the flurry of internet messages and emails and texts and whatnot about, hey, get out there and see them. And I went out and it was cloudy at my house, so I didn't get to see that. That was Tuesday night.
Yep.
And I've never seen red before. so I wish I had. And then the next night we went out to Spring Green, where I thought, oh, no light pollution, this will be perfect. We'll see something. Nothing happened. So that was too bad. Okay, so thanks, Pete, for showing us that. I'm so glad we made the investment in those rooftop cameras for so many reasons. They're excellent. It's also been a week of storminess around the western hemisphere of the northern part of the globe. A couple of places that I wanted to focus on, not in the week-long term. So I don't. Yeah, I don't want to see this today because I'm not ready to talk about it. But the current map is the maritime provinces of Canada and the southern part of the Labrador Sea. It's been very stormy. And here's the latest beast heading toward Newfoundland. I think it was last week or maybe the week before that we had back-to-back major events in that part of the globe. One of them down to 950 or 942 millibars, the other one somewhere in the low to mid 950s. And as you can see, at this time of year, the ocean at high latitude is still relatively warm. Consequently, when you get a big cyclonic circulation up over the maritime provinces and it pulls the air off the continent, that air is usually quite cold relative to the ocean, and so you get this beautiful set of cloud streets putting in there, and you can see the spacing between the sort of clusters of the clouds varies, of course, as the distance goes on, because there's more and more convective and latent heating going on as the air comes over relatively warmer water. And, a couple of months from now, this part of the North Atlantic is not going to be that warm, but it's always going to be substantially warmer than the air that's cooled over land. And the Gulf Stream is right in here. And so it's on the southern boundary of much of that cloudiness that we see today. So that's one storm out of several. And we just had our first forecast discussion for the Nurture program, which will be based out of Goose Bay, Labrador, from through January and February. And with about a 3,000-mile range for the aircraft that we have to kind of focus on events that really reach maturity or peak their head into that portion of the world. So New England, the Middle Atlantic states are just about at the extreme. Maybe James Bay is at the extreme. And we don't go much over water, so it's going to be things right in the immediate vicinity of Newfoundland, Nova Scotia, and Labrador. And but we have something on the offing for like Monday and Tuesday. And that has something to do with a really beautiful upper front that's going to develop in northwesterly flow across southern Canada. So we'll see elements of that feature in the current weather discussion, and perhaps something more about it in the forecast. And then off the west coast, we'll get a better view in a minute, but it's also been stormy in the Pacific Basin. And so quite a number of disturbances have reared their head and developed in that region, and some of them have crashed onto the coast. There's one right now that's bringing precipitation into the southern part of the valley of California, and it'll move to the northern part of the valley. And you can see, here's the cloud street. Atmospheric river, I guess people will call it, but it's tied to a development, in this case, a very obvious connection, and as they very often are, but not always. And so we'll take a look at that in a minute. And beautiful weather over us, and it's going to keep getting better, and we'll see why. There is a beautiful, really quite potent lee-side trough over southern Alberta, southern Saskatchewan, and eastern Montana. And wait till you see what it looks like at 850. It's just unbelievable. It's like a 25-degree temperature contrast across that thermal ridge. And we are on the southwesterly flow side of that feature, so strong warm advection prevails. And it's fairly uniform warm advection, which is an important factor because it tends to keep clouds out of the sky. So it's not concentrated, and therefore it can't really produce much vertical motion. And even if it were able to, some of the air that's moving to the northeast in that southwesterly flow has been desiccated by its subsidence. That's the only reason it's warm. And so it takes a lot to get that air to start, getting to 100% relative humidity. It doesn't hurt, though, that the more or less uniform temperature advection really puts the kibosh on QG omega. So that's going to be interesting to see in the current ops. Okay, so Pete, if we could go to the West Coast satellite movie first, and then we'll come back and look at the radar across the country. So here's best we can do at this time of day is the infrared. Every once in a while this fall I've been commenting on the ITCZ. Here's the state of Hawaii. And this time it's fairly active. So there have been several Fridays where it's been, looks like a first grader's teeth. There's a lot of holes in it and so on. And you never heard that before? Really? I'm surprised. It's a perfect analogy for that kind of thing. Picket fence might work too, but we're going to see in the upper level charts there's a big strong circulation, cyclonic circulation here. And this particular one has very much tapped the subtropical moisture in the ITCZ, and that's brought this feature straight up into the southern right now. southern part of the Valley of California, and we'll see in the radar that there's some precipitation there. There was yesterday anyway. Even without seeing the geopotential height field, though, with this depiction, you can sure see this is a wavy flow. So there's a big cyclone well past the date line, and then another one to the south, and then strong flow from the southwest to the northeast. Crests a ridge, comes back down, here's the second wave. So a lot of wavy activity there. And there's a big storm brewing in the northern prairie provinces of Canada into the northwestern Yukon territory. And it's going to be on the southern periphery of that lee side trough starts to take on a character of its own as a cyclonic disturbance late through the weekend and into the early part of next week, which will have a rendezvous with Destiny in the Nurture dry run right now, that Andrew Winters is in charge of at the current time. So, and he's got a superposed jet tied in with this upper front that's going to develop, which is really nice. Okay, so that's the picture. No particularly well-organized cyclone right now in this field of view, but you can see that it's a wavy flow, and that makes it interesting to talk about. Okay, so let's go to the radar first, Pete, and then we'll take a look at the eponymous super Petes. So here's the national radar mosaic, and you can see a few precipitation elements coming across. I suspect there's probably, we'll see when we go to the upper level charts, this is probably some moistening over Lake Huron and then maybe a little bit more over Lake Erie, and so a little bit of light precipitation. I don't know what the temperatures are there off the top of my head, presumably chilly. I don't know if it's snowing here though. And then there's a little bit of high terrain in northern New York State that may also be a factor in producing something that looks like lake effect precipitation. In the central part of the country, not too much, as you can tell outside. And then here's the precipitation in the Valley of California. It was a little bit more connected yesterday than it is today, but put together better, I guess I mean. And then some precipitation, as what we'll see, this is kind of the cold frontal portion of a lee side trough thermal structure across Montana, and then a little bit of precipitation in the Puget Sound area associated with the cyclone that we'll see in a minute, that we just saw. It's just sort of right offshore at that time. Okay. So most of the country enjoying a really nice day weather-wise. Which is great, and we're middle of November. I mean, tomorrow really is the actual middle of November, and we'll probably make a run at 70 degrees tomorrow, which is just unbelievable. And I think you said dew points will pop above 50 degrees.
Yeah.
Unbelievable. Okay, that's just unreal.
Also, if I could ask
Yeah.
the state climatologist folks, what's the average temperature for this time of year for Madison?
Madison, I think the average high is like mid-40s. Does that sound right?
I think so.
And then so what, upper 20s maybe for low? So yeah, this is 20-some degrees above normal.
So
Yeah.
looking at, you showed the map of the temperatures in early October. We're going to be kind of close to what early October temperatures will be.
Yeah.
And the leaves are still here like actually.
Yeah. That's amazing. It's just amazing. And in fact, tomorrow it used to be, I think it's been adjusted in the last 30-year climate interval, but in the prior one and in ones prior to that, November 15th, I think Reed Bryson told me, was the 50-50 day for precipitation, which means this: if it precipitates on or after November 15th until sometime in the middle of March, there's a 50% chance it's snow versus rain. And then that percentage for snow, of course, climbs the further you go into the season. But that's the first day on which climatologically, and as I say, I think this is a past climate reality. It might be even further into the future now, but that's a 50-50 day, which is pretty neat when you think about it, right in the middle of November. And it tends to correspond to our snow. Everybody, when we saw snow last weekend, everybody was saying, oh, this is a little bit early. Nobody said it was wildly early, but a little bit early. Everybody has a sense of that. So it was about a week early compared to that climate. I wish I had the update. I think it's been moved closer to Thanksgiving, but somewhere in maybe around the 20th of November now. Okay, let's go to the super Petes. Pete, let's start at 500 millibars, please. So here's the 7 a.m. 500 millibar map. And you can see the complex, a deep upper trough over the Maritimes and northeastern United States. Here's Newfoundland, and a little bit of a short wave in that feature, embedded in this deeper long wave trough, and that's where that big cyclone was. It busted out over the island. Fairly intense little cloud burst and development. I don't know what the sea level pressure got down to, but it was pretty low, down in the 970s, I believe. And then here's a patch of minus 32 degree air, so at least minus 30, in another short wave just south of James Bay. So that they're all pinwheeling around this broad upper low. And so each one of them, when they get out over the relatively warm water, can spawn a little bit of a organized convective activity we'll probably see something else make its way towards Cape Race by, Saturday night into Sunday. But the main kind of things that are about to evolve are really quite interesting as well. There's the cutoff off California. The precipitation feature in the valley is related to this, of course. But here's another wave in western Canada, bordering on the prairie provinces, coming out of mountainous Canada. Look at the temperature contrast at 500 millibars and the obvious thermal ridge at 500 millibars. This is really a rare feature. You don't see them that dramatic at this elevation very often unless you have a deeply occluded cyclone, or unless the wave has traversed high terrain of 10,000 feet or higher, which it's just done. And so there's subsidence warming over the prairie provinces, almost surely contributing to the thermal ridginess here in this isotherm pattern. We'll see that's clearly the case the further down we go in the atmosphere. But what it does is it produces pretty strong cold advection across southern Saskatchewan, southern British Columbia, Manitoba and British Columbia, Alberta and British Columbia, and pretty strong horizontal shear at 60 knots north of Calgary, and then almost a zephyr wind near Great Slave Lake. So this cyclonic shear and cold advection, that tends to mean subsidence right through the jet core. And so this is the feature that starts to develop as an upper level jet front system. It's quite weak right now, but it's got the initial conditions for that. And then it's got a nice little runway all the way out to the northern Atlantic Ocean, because it's just a little bit of a ridge it's got to conquer across the central part of both southern Canada and northern United States, but it's going to make its way through there in the forecast. So that's the feature we have our eye on for a Sunday night, Monday development in the Maritimes. And then there's more such features upstream, as you can see, but not at a very good angle, so right out south of the Aleutian chain. So pretty active wavy flow in the middle and high latitudes, and they're gradually encroaching, of course, on us, and that's a factor for the weather and the likely changes we'll start to see in the next month. Let's go down a little bit, Pete. Go to 300 millibars. So here's 300 millibars, a sort of almost disconnected polar jet coming across with some waves in it. And then this feature here, if we had more time, I'd probably have spent some time looking at how it got itself divorced from the main westerlies, but it did. And so this is the cutoff feature off the coast of California. Usually that's a function of a big ridge that kind of breaks, and then you get this vortex substance that makes its way further south than it probably should be at this time of year. It just hasn't gotten that cold over the hemisphere yet. So this is very anomalous. Everything here is not so anomalous, and that's kind of the way those things go. But there's flow across the high terrain in Canada that is pretty intense, 120 knots across the Rocky Mountains, or about like that in Canada. So there should be strong subsidence in the prairie provinces of Saskatchewan and Manitoba. So let's go to 850 millibars at this time for the big reveal. Look at that. So there's Lake Winnipeg, Manitoba, Saskatchewan. Look at this incredible thermal ridge, which is associated with an obvious geopotential height trough as well. It's 19 degrees in central North Dakota at 850. So that's about 1,400 meters above sea level, and it's that warm. Meanwhile, at Green Bay, it's +5. So it's really, really warm in this subsided air. And then look at how this temperature gradient over here to the north and east is characterized by geostrophic flow across it. And so that's where the warm advection comes from. So when you're enjoying 60-something degrees tomorrow, you can thank the Canadian Rockies, because without them, this wouldn't be the case in this scenario. And then in the wintertime, I often thank the Canadian Rockies and the U.S. Rockies for the light flurries that we get in these warm advection regions, if it's not so uniform as it appears to be this time. And in fact, it's not that uniform, so there might be some clouds in the sky tomorrow in the warm advection region. But it's a really intense thermal ridge right over the border between Saskatchewan and Manitoba. And that feature is south of the main cyclone we saw in the satellite movie. And this is the vortex feature that kind of barely survives across its traverse the western Great Lakes, and as the upper front develops in the northwesterly flow, it kind of picks it up and turns into a big storm over the Maritimes. So it's a story of intestinal fortitude, how that vortex hangs in and waits for the deliverance from aloft, which it gets.
John, this is not a scientific term, but I would say that cyclone looks pretty goofy, almost cartoonish.
This one?
Yeah.
Yeah.
Just the structure of it. I mean, the elongated pressure trough in this sort of elliptical shape.
Yeah.
And the really intense warm thermal ridge, which is characteristic of a cyclone, but Just the location of the pieces.
Yeah, it is weird. Can we go back to the 300 millibar map, Pete? I'll keep my finger there and right here on Lake Winnipeg. So 300 millibars. Look at how the cyclone to the north is kind of in a nice position. Not just the jet exit region, just a little farther away from that, but it's in a region of strong cyclonic current. So it's developing in association with this wave and the jet. But the thing over Lake Winnipeg has nothing to do with that. It's in a ridge.
Right.
And so it's purely the orography producing that warm bubble which lowers the geopotential heights in the lower troposphere. And so underneath a ridge at upper levels, you get a trough because you've warmed the air. So it's a really weird structure. And it's composed of two pieces, one of which obeys all the normal dynamical rules, the other one that is really locally forced. And what happens is the feature upstream, it looks like to me, the feature upstream intensifies and picks this one up.
Yep.
And that's how it develops. And it doesn't have to do that, and they don't always do that. But that's what ends up happening in this case. So that's the setup for what I think is about to occur. If I can show you just a couple of forecast maps, and we can use, well, we'll just go to Alicia Bentley map, because that's an interesting way to look at this, I think. Well, that's a young voice. Oh, no, it's not. I thought it was. Okay, and can we go over the continental North America? Yeah, great, okay. So this is right now. So there's no obvious feature that we're going to be watching involved in the northwesterly flow. There's our thickness ridge now instead of 850 temperatures in the same place, but still the cartoony looking cyclone up near the northern part of the chain of lakes, that's controlled by the upper trough. This one here is driven by substance, but they're connected somehow as one oblong low pressure system. Can we click ahead one or two times, Pete? Okay, one more time, right there. So this is the main cyclone. Now it's near Churchill, Manitoba. It's kind of nicely developed, strong cold front, little bit of a stubby warm front, maybe even a hint of a thermal ridge in the thickness field. Here's the trailing vortex that started out as the lee side trough feature, and it's not gone away. This is not just a regular pressure trough in which the cold front sits, because that's a thermal ridge that goes right through that low pressure trough. So it's a little bit of a weird structure, right? Watch this feature in the northwest flow. Go ahead a little bit. Keep going. Now, this is an elongated jet, and the thickness lines cross the jet axis just slightly at this time, not that much at this time. One more time is even better. Now they do a little bit more. And so one way to think of this is there's a cyclonic shear side and an anticyclonic shear side of the jet. And if the thickness lines cross the jet axis from the anticyclonic shear to the cyclonic shear side, as they're just beginning to do, turns out you can find that that's exactly equivalent to cold convection along the jet. But it also produces subsidence right here through the jet core. And that makes the upper front get more intense. Part of a frontal structure is the vorticity. The vorticity at upper levels gets more intense. And what's the beneficiary? The downstream region of low pressure, which is in the location where the thermal wind is lodged, and you will have produced a substantial upper vortex. And so you have strong PVA by the thermal wind. So I'm arguing today, here we're based in Goose Bay. This is right on the periphery of our range, unfortunately. In fact, it's probably past it. I'd love to go and sample this thing first, a couple of times, then see how it leads to development. We just don't have the resources to do it. But that's what's going to happen next, is northwesterly flow, in the northwesterly flow, a modest upper front, not the strongest one, but strong enough to really energize this development and turn it into what would be, if we were there, an intensive observing period. So that's pretty neat. It's going to be fun doing this every day for the next 2 months. But that's all. One more thing I have, and that is our every 2 week update on the cold pool. Where's the HDMI? Oh, it's already in here. Thanks. Okay, so a little bit of a change in the last 2 weeks. The basic tendency, though, has been the same. We're below any of the last 30-year climate averages, and we're the long-term one, 48 to 2014 in blue. And then in the midst of our relatively local cold spell with the snow, the hemisphere is warmed up. It's always the way it seems. It never seems to be in phase with us. So the whole time series from September 1 to now, November 13th, has been below or maybe at the average. And that's led to us being tied for the 8th warmest, September 1 to November 13th. And I forget what year we're tied, 2011, I think, or something. So we're hanging around in the top 10, but I don't think we're going to move much higher on the list, and I don't think we'll fall by December 1. And that's when I stop keeping track of this portion of the season and then start thinking about December 1 through February 28th. So all of the stuff Amanda said was a regional manifestation of the dice being loaded on the hemispheric scale as well. We're warmer than we should be, and we are every single year now. And those Chinese climate hoaxers are really smart. Whatever the president says, right? They figured it out. So we've got something really going on, and it's testified to every single fall and every winter. So that's all I have. Any comments or questions? Yes,
Do you
Steve.
keep track of the forecasts of this? Is it always diagnostic after the fact?
I don't keep track of the forecast, but it's easy to do because you could just I used to do this. Brett asked me to do this at 10 days and maybe to 14 days. So I haven't done that. That would be really fun to see because you'd have the whole bifurcation of lines from this point and then see which one's the true one. It would be really an interesting analysis. And I wonder if in the ensemble of forecasts, since this is a hemispheric value, if the hemispheric average is going to always be just about well forecasted, even if regionally, of course, you'll get some things that are wrong. That would be interesting to see. So I don't do that yet, but maybe I will now upon that question.
Great. Do we get the CFS data, Pete, on the forecast system data?
Don't think we do, like, check.
How far out does that go?
A month.
Oh, a month.
That would be kind of neat to.
Yeah. Really interesting. Because, then you'd start, well, it's hemispheric. It wouldn't be useful for business. Regional ones would be useful for business, though. What if you knew you were going to get some kind of underperforming, it's not going to be as cold regionally for the next month?
Right. But I bet for energy
Somebody would want
markets
to know that.
For energy markets in the winter, knowing if Europe, Asia, others are going
Yeah.
If that measure can be useful in just, saying something about the hemisphere
Yeah.
energy usage.
Yeah, it probably would. It probably would be. Yeah, that's good. Oh, that's all I have. Thanks for that question, Steve, though. That's prompting me to do some more analysis.
That's good. Thanks, John.
Okay, thanks. So we'll first start, we'll go to Kai first. So the key things that are going to be coming up, just follow my list here. John showed that weather system that's going to be passing by. We're going to get the frontal passage sometime early tomorrow morning, sometime between 6 a.m. and 8, not that, we'll go down to the time height section. And this really shows a nice dramatic frontal passage. Possibility of some early week snow. There's a big question mark next to that. And then we'll look at some of the other things. I think the highlight, the most interesting part of the short-term weather at least, is going to be tomorrow's high temperature. As John alluded to, we could be approaching 70 degrees. Certainly the middle to upper 60s is possible, but that's going to be after a frontal passage, which I think is also kind of neat. So again, here's our time height section. Here are isotropes in yellow, relative humidities in red, dynamical tropopause at 1.5 PVU that appears in this particular cross section. A little bit of low-level PV with a high stratification that occurs. But the things to note here are really strong evidence of warm advection with the winds varying with height in the lower levels of atmosphere. And coupled with that, you can see the isotropes getting lower, getting sort of steeper in this direction or trending downward with time. So warm air flooding our region. And that's all that warm air that was produced from substance over the Rocky Mountains sort of headed our way. But even with that occurring, we're beginning to form this stable layer, fairly strong stable layer, but even with the layer there, really strong winds beginning to develop as the pressure gradient tightens in the lower troposphere, winds getting just above the surface at 30 knots or so. So a pretty windy evening this evening. Also, you don't see much of the outcropping of the isotropes near the surface, indicating the radiational cooling occurring. There's going to continue a well-mixed layer, even though it's not particularly deep, over us overnight. So tonight's going to be a relatively warm evening.
That's a really good point. That's a rare instance to see them like that.
See that. And then, as we go into tomorrow, notice the winds beginning to become go from southwesterly to more westerly, and then ultimately northwesterly by early afternoon. That's the passage of our front. Cold air really begins to come in. But at the surface, we don't really get these isotropes sort of, again, popping out of the ground too much. So we're going to stay warm over the day tomorrow, at least as warm as we are today. think the last observation at the airport was 15.6, so 60 degrees, and we still have a ways to go in terms of warming up. And that warm air isn't too far up, so if we can mix down even more, we could really burst through this inversion that seems to be trying to form and warm up significantly during the day tomorrow.
I wonder if part of that is that what you're calling the frontal passage is the wind shift, and it may just be a lee side trough still.
That's an interesting point.
Shift
That's
comes first, and the temperature is the colder temperatures are much farther to the west.
right, because I guess, looking at this, we don't see much of a horizontal temperature gradient up here.
Yeah.
But aloft, we see where that gradient is. The cold air is definitely coming in, right? These are beginning to steepen up, so that's
Yeah.
colder air. But at the surface, it really hasn't happened until you get really further into the,
Yeah.
later in the day. So that's a good point. That wind shift tomorrow could very well be, as John said, the lee side trough, the trough part of it coming through. The cold air really isn't, if you will, caught up certainly at the surface.
Yeah.
But then tomorrow afternoon and evening, once you can begin to see these isotopes beginning to cool down, cold advection really comes in, temperatures drop. So that on Sunday, instead of being in the mid-60s, we're probably going to be only in the mid-40s, so it's going to be a fairly chilly period. Other thing to note with that frontal passage, and it's probably kind of hinted at looking at the radar, just a brief period of maybe some cloudiness early tomorrow morning between 6 and 9, and then just dry. I don't think precipitation is going to be really anticipated in these conditions. If we go to the meteorogram, I wasn't going to show it because dew point's still screwed up. I haven't fixed it yet, but I've done some digging. I think it's because of the fact that in the code that produces this, it's not a GEMPAC issue, it's a coding issue. The pressures are given, in order to compute the dew point, we don't have that as a model variable. It's using pressures that are in pascals, but it thinks it's in hectopascals, and it's doing something screwy with the water vapor conversion. So, in any case, but you can see in the forecast, this is suggesting, maybe tomorrow just about the same as today. This is already under forecast for today. We're at, again, 15.6, and we're probably going to get into at least the mid-60s. So I think certainly mid-60s tomorrow is possible. In terms of precipitation, again, bone dry for the period. So we'll get out of this. Some issues with we're going to go to pivotal now. Look at that. Oh, before we do that, let's just step through at the surface. These maps were messed up today, so let's start at the 6-hour forecast. And again, this is valid for 18Z today. This has us just only about 13 degrees Celsius, which again is, that's 56, a little too low by 6 degrees or so, 5 or 6 degrees. But strong warm advection occurring from the south. Let's go ahead to, let's go to midnight, so 18 hours in the forecast at the surface. Again, temperatures really haven't changed much. They're forecast to be about 12 degrees Celsius, so that's going to get us still in the mid-50s. So tonight's going to be a relatively mild night. But if you go further back to the northwest of Minneapolis, St. Paul area, you can see the winds have already begun to shift. There is a bit of a temperature gradient here, so this might be the beginnings of a front that's beginning to set up. But again, for us, broad southwesterly flow, we're still going to be mild. Let's go ahead to tomorrow morning, 12Z. We'll see that wind shift is just on our doorstep, if not just over us. 24 hours, so please, just to get when that wind shift comes through. Okay, we're still just westerly. Again, Milwaukee's still a little bit more southwesterly. Here comes the beginning of the wind shift. Minneapolis is already in the cold advection period, and from the looks of this is weak cold advection, right? The winds are blowing through, but we still are going to, looks like we're going to manage to warm up a bit. So that's when I think roughly the wind shift has certainly just gone by at 6 a.m. Let's go ahead 3 hours. Okay, still northwesterly flow, even getting stronger and more out of the northwest in the northwestern part of our state. Here in southern Wisconsin, again, northwesterly flow, and again, dry over us at this point. But weak cold advection. Let's go ahead to 18 hours in the forecast. Not 18 hours, excuse me. 18Z, 30 hours in the forecast. And we've managed, you can see these isotopes. So we have the cold advection occurring, but we're still warming up. So that indicates a lot of mixing from the surface occurring. So it's not just, potential temperature, certainly not conserved in this. We have heating occurring, and it's mixing up so that we're beginning to warm up a bit. So that gets us just to where we were today, right now, and we expect that to probably be, we're gonna overshoot that. And we'll go to 21Z, so 33 hours on the forecast. Thanks, Pete. And temperatures now beginning to fall off by mid-afternoon tomorrow, as this cold advection has certainly taken over us. But you can see broad cold advection across parts of southern Minnesota and Iowa at this point. So what I want to do next, before we switch to another set of maps, is if we could bring up the, in the weather program, the MOS forecast. This is the model output statistics for the GFS. And again, it has us getting up to about 66 today by 21Z, and then temperatures staying relatively mild, 53 for a low tonight, high tomorrow before 0Z, but we know when this is going to occur, sometime probably in the very late morning, early afternoon of 67. And then we drop off pretty smartly down into the upper 20s, below freezing, and then only mid 40s by the time we get to for the high temperature on Sunday. So few clouds, as we kind of predicted, looking at the time height section, broken, scattered, and then sort of during the day tomorrow. That might be the one sort of fly in the ointment for us to get super warm, is just how much cloud cover and what level the clouds are. But you can see the wind shift. Again, we have winds out of the southwest, south-southwest, and then becoming westerly by between 12Z and 15Z, so between 6 and 9 a.m., and then more northwesterly after that. So it gets pretty warm tomorrow by in the early afternoon, and then temperatures are going to start their drop. And then clearing skies tomorrow evening. Probability of precipitation type, obviously, is going to be rain until we get to 6Z till midnight on Sunday, when it's, the most likely precip type is going to would be snow if it were to occur. And you can see here, the wet bulb temperature is probably going to be will definitely drop below freezing. So any evaporative cooling that we get is going to give us, even if we're warm, will give us frozen precipitation. And the other thing I like to do when I look at MOS of this sort, if we could just go back let's go back to 0Z. Let's look at the last few runs of the MOS. So we can do MSN 0Z dash. All right, so from last night's run of MOS, 65 for a high, 67 for Saturday, with a low of 52, and we can just page through that. The 6Z MOS, 67.53, high 66. So this is pretty consistent in terms of keeping us relatively warm.
And a warm overnight is not an aberration.
Yeah, so this is going to be warm, and then the next one is going to be the 12Z run. So that's something you can look at for that. Next, let's go to pivotal. Forget that, and just take a look at the forecast as we go a little bit further into. It's still up there. There we go. And we'll go to U.S. So national. Click on that, please. Surface map. Yeah. And again, this is this cartoonish looking cyclone in Canada with this big, broad, sort of baggy trough that extends across those provinces. Pretty impressive. Let's step forward, and we'll just go first, immediately 24 hours in the forecast, so tomorrow morning. Okay, so that cyclone, the main cyclone that John had talked about, has now moved into north central Canada, but we have this area of lower pressures at the head sort of the thickness ridge as it moves further to the east. Here we are in that broad southwesterly flow, really uniform, very weak temperature advection to begin. Where warm advection will mix down that air that came off the high terrain to our west. But the key thing is, this is warm advection. It's pretty clean. I mean, the clouds are going to come in probably more with a frontal passage, but this looks dry. If we go ahead to 27 hours, as the wind shift, at least in the GFS, is a little bit delayed. Okay. That time we're sort of more westerly winds, or still west-southwesterly winds. So there could be a slight difference in timing, with the frontal passage or the trough axis passage in our forecast, it's still probably just toward northwest at this point, just looking at this. And we have the westerly flow here, more northwesterly there, so it's just toward northwest. So,
The 6C run, by the way.
oh, let's go.
That's actually,
Okay, that may be why it's delayed, because I'm not in phase time-wise. Yeah, still,
this is the 27.
and that's definitely a frontal passage, or, yeah, a frontal passage. We're in the cold advection. So I take that back, I was looking at the wrong run from 6C. But there we are in the cold advection, it's definitely started. Cyclone's now beginning to consolidate itself in the sort of the head of this ridge, at the crest of the ridge. A lot of precip to the north, not much with the cyclone center itself, because a lot of this air historically has come from over the Rockies. It's dry air, and as it gets entrained to the system and it begins to lift ahead of the trough, that's where it gets the saturation occurring, the precipitation as well to the northwest of that. So let's go ahead to, let's go to 48 hours, Sunday morning. All right. Ridge is beginning to build in over us. Cold advection is still fairly prominent. This is anticyclone moves east and east-southeast. It's fairly dry, and if we look upstream, weather looks fairly quiet, at least based on the surface map. Let's go to 72 hours, Monday morning. And at this point, the high is, we have this ridge, but it's sort of begun to collapse over us. But we're still in some weak cold advection. Warm advection is beginning to set up over the northern plains to our west, and from the Gulf of Mexico, it's beginning to open up with flow out of the western Gulf. So we have a source of water vapor for precipitation. The next question is just what's the setup going to look like? Let's go to 500 millibars first at this time. Okay, so at 500 millibars, we have a pretty smart-looking shortwave trough, really strong curvature associated with it. So this could become a potent feature if it were to get over us. The issues that it's going to confront are we have this broad confluent flow over our region. So as this moves to the northeast and comes back over the ridge, will it just get sort of squished by the broad confluence that exists to its east? Let's go ahead to 84 hours. 12 hours from this time, so this would be there. So it's made it to the north over northern Nebraska. What a state, Nebraska. Any case, we have this confluent flow over us. We have a nice shortwave trough. We had cold air over us. If it's still over us, this might be an interesting setup for precipitation if two things are true. One, if it's still cold enough, but secondly, if we have any water vapor getting up to our latitudes. We saw the Gulf was open at the surface. There's more advection occurring, winds veering with height. And so let's go back to the surface map at this time at 84 hours and take a look at what we have. But the confluent flow is going to be so there's the precip beginning to set up, at least in this particular model run, and it's falling in the form of snow. We'll look at the surface temperatures in just a second. But we know we had temperatures, or the forecasted temperatures were mid-40s for Sunday, and probably Monday just as cold or not colder if clouds begin to move in. But here's an area of light precipitation that begins to set up. Let's go to 90 hours as the precip begins to sort of more blossom. Notice, at least at the surface, you can imagine a flow out of the south. Look at 850. There we are with a little bit of light snow. 540 lines up here, but we don't really care about that. We want to look at vertical profile. So let's take a look at a sounding right over Madison. That was Middleton, but okay. And saturated through a fairly deep layer, but this is the thing that we're going to have to confront, is the lower surface being just dry.
12-degree dew point.
Yeah, so our dew point depression is going to be what we're going to have to overcome if we're going to get any precipitation. But if it were to fall, snow would be the best guess. So that's at 90 hours. Let's click ahead time-wise by 3 hours. Can we get any of this down to the ground? It's trying, right? Precipitation is probably falling, but the air is so dry, but the dew point's gone up, 10 degrees in that time period, and we're holding steady in the low 30s. So, Tuesday's going to be a chilly day. Light winds, maybe easterly winds here at the surface, as we have that lower pressures to our south. And we go ahead one more 96 hours, look at the thing. So we get close to being saturated. So there's a possibility of snow. But if we were to get out of this, and the map hasn't adjusted to the time that we're looking at, let's just go a little bit further south to the Illinois-Wisconsin border. And this is back at 90 hours. That's actually surprisingly still, okay, there, they become saturated there. So that's where the, it's just amazing. It's saturated all the way.
Yeah, we were dry,
Okay.
except at the ground in the last
Right.
one over Madison. So snowflakes can't make it through the
Yeah,
ground.
so let's actually, at this time, we'll go to 90 hours in the forecast, check on the shortwave trough that was just to our northwest, so 500. Okay.
That's the snowbird.
So again, nice curvature. It's not as sharply curved as it was earlier. Again, we'd expect to see ascent, all things being equal, just to the east of this upper trough as it moves here. But again, we're in this confluent flow, so this is definitely going to get squashed. Let's go to 93 hours, please. Okay, you can just see it beginning to weaken over time. The other thing is, let's just zoom in a little bit. We'll go to regional. And then over the upper Midwest, or over us. And then let's go to 850 temperature and wind. I think this is a pretty good time to look at it. Again, see, let me get this right here. Here, this is actually frontalytic out here to the west over parts of northwestern Iowa. We have these weak winds here, and then they begin to speed up further to the north in the cold air, so that's frontalytic. But I think we'll see, this is at, oh, this is actually past. Could you go back to 87 first? So for us, again, we still have that northwesterly flow at 850. That is weakly frontogenetic in this region. And then to the south here, that's not really strongly, I think that's at best weak frontogenesis.
Yeah.
Go to 90 hours. I have to get my timing. That's a little bit better. Southerly flow here, and then it becomes more diffluent to the north, so that's going to help concentrate the isotherms. But it's down here, and I know that this is a tilting surface, so if this pattern were to be maintained a little bit further to the north, that could get us into a zone of frontogenesis. But again, we'd expect the heaviest precipitation to be maybe just to our south. So let's look at the accumulated precip at the very bottom for snowfall, assuming 10-to-1 ratio. Yeah, we could just do total, and then just step this forward, please, a few times. Okay, so spreading along the border to the south, 0.3 of an inch isn't too bad.
Hey, 1.1.
1.1.
Could be our first inch.
But yeah, so this is where the majority of the precip is going to be, and those totals are probably going to out to the west. If you looked at 6-hour accumulated amounts, probably begin to diminish as that wave gets squashed, and so the southerly flow ahead of it is going to weaken. But let's do what we become used to doing, and just compare some model runs right here. Compare model loops. Let's do that. I think that's what I want. Yeah, and we have a collection of forecasts for this, all valid at the same time. Let's look at that's total snowfall. So GFS 1.1. Let's go to Eastern UW-AOS. Nothing. That's too dry. Eastern WF has the heaviest precip down here. How about our Canadian friends and their model? Looking dry.
No snow, eh?
We know this. We know here, a little bit to the north in the icon, that's the German model, and I think UK Met is similar a little bit to the north. So the GFS is in a weird place with this. Did this exist if we looked at the 6E run?
Oh.
Yeah, so this getting chopped off down here is because it's all liquid precipitation, so a really intense thermal gradient. And if we looked at the sampling of model forecast, we only have the AIFS, and the icon shows a little bit more to the north. And then finally, let's look at the 0Z runs for these models. So definitely a shift northward in the GFS relative to its earlier runs, and then we go across the suite of models. We hope with this Eastern WF is kind of hanging in there. Not much in the Canadian. The German model is to our north, and the UK met just to herself.
Wow.
This is
we're on our own.
yes.
Something that I
Tyler.
noticed when you played the soundings back to back.
I'm sorry, I missed it. Yeah.
Yeah, when you would do the soundings, there was this very strong dry layer. But as you went from 90 to 93 and then 93 to 96, it actually was moistening up at the surface before just above the surface.
Right.
And I saw that it was easterly winds, and so I was wondering if the GFS is thinking that some lake moisture might be helping to make it less dry at the surface, which might explain why it has stronger precipitation values making it to the ground.
That's a possibility. I haven't done enough analysis of that. I don't know, John, if you'd want to weigh in on that.
You'd have to have the right wind direction, but it
Right.
could.
The winds were easterly, yeah.
Was it easterly?
It was easterly.
That's probably a viable explanation.
Yeah. In fact, let's
And
look
it was
at-
the same thing. We had
Yeah.
that dry bubble just
Right.
above the ground, and the last one we set up in Madison, we just can't do anything about it. It's not enough precipitation to saturate the
Well,
coast.
the-
You have the
But it was at
lake
the
nearby.
surface that then started to moisten even though above it wasn't. So it means it's coming
So,
from different sources.
yeah, so with an east wind, and let's go to the 6-hour amounts, please. And we probably want to go back to 90 hours.
It was 90, 93, 96.
Yeah. It's hard to, I guess the one other thing-
Like surface
Look at-
relative humidity.
yeah, let's try that.
2 meter relative humidity.
But remember, the relative humidity is not going to be advectable,
Yeah.
right? We'd want mixing ratio. Unfortunately, that's the one thing that these sites don't show. That's at, this is what, 90 hours, and go to 93, please, Pete. That's a good point. What's happening? Yeah, it just doesn't seem like that's necessarily going to be a factor, but how you get moistening the lower troposphere without doing much up just above it is a little bit weird,
Yeah, it is.
and that's dry. What is that? That's a theta E, right? So that's going to be the, I think the big factor for us will be, one, the forecast. The GFS kind of stands out like a sore thumb. Get excited about the snowfall, but you want to look at the collection of forecasts. But I think the things to watch this weekend are going to be the return of water vapor into the central and southern plains over the weekend as the high begins to shift a little bit to the east and the flow becomes more southerly. And that might be the determining factor. That's probably going to be the determining factor on how far north that precip band occurs. But the other thing is the frontogenesis was modest. The upper trough itself was somewhat modest. We could compare the, say, East WF's upper trough structure. If it's a weak upper trough or it gets squashed too soon, it's not going to be effective in helping us get any sort of forcing for ascent over us. So a lot remains to be seen, but I wouldn't, I still think there's a possibility of maybe light snow,
Yeah.
or certainly, where's clouds, John? We get some clouds on.
Some cloud gray, a gray cold day is almost as good as a snowy day for me.
You heard it here. Okay, John does not like snow. That's what I heard. Okay, and finally, if we just, let's go to 168, we'll go back to the surface. We're sitting here next Friday. And next Friday, mild again in another cyclone in the central part of the United States moving northward. We can just look at the national map. Okay.
Oh, yeah, look at that sucker.
And we can just get out of this view if we want to. In any case, the week starts off cold, maybe a little bit of snow, and then I think things begin to get a little bit milder as we move toward mid to late week. But a couple of interesting factors are the 6 to 10 day outlook, and I think the 8 to 13 or whatever are all above normal precipitation. So the central part of the United States is going to get rather wet, and the temperatures are expected to be above normal for the next 2 weeks in general. And if we go to the very bottom of this, total precip, not the snowfall, that, and go to the 384 hours, you can get a sense of how wet things are going to be over the central U.S. So a pretty wet period. A lot of this is with the initial atmospheric river that hit California yesterday, and then that's pretty wet in parts of central Oklahoma. So again, don't look at these numbers explicitly, but this gives you a sense of the flavor and distribution of the precipitation over the next 2 weeks. So a wet period coming up. But unfortunately, it's not going to be super cold. I think the GFS does have a snow event for us somewhere in the 220 to 260 range, but We don't need to look at that.
It also suggests no snow in central and southern
Oh,
Canada
that's a
for
good
the
point.
rest of the month, which means the refrigerator's not turned on yet.
I did get my freezer fixed
Oh, you
today,
did? That's good.
this morning, so there's something. Okay. Enough appliance talk. Thank you, Pete. Thank you, State Climatologist Office, Amanda. Thank you so much. And thank you, John. Have a wonderful weekend and enjoy the warmth tomorrow before the chill comes in.
Thanks, Michael. Thanks, Pete.
Yeah, so what was happening down the surface? Why do we?